I've calculated thousands of orbital trajectories in my career. It's fundamental physics, Newton's laws, Kepler's equations, Einstein's corrections for extreme gravitational fields. These are some of the most well-understood, precisely tested laws in all of science. We can predict the position of planets centuries into the future with extraordinary accuracy. We can send spacecraft to distant worlds and arrive within seconds of our calculated arrival time. Orbital mechanics is not mysterious. It's not uncertain. It's as close to absolute truth as science gets. That's why what happened 3 days ago has shaken me to my core. I was in my office at City College reviewing data from our ongoing observations of 3I Atlas when my computer screen suddenly filled with urgent notifications. JPL had issued an immediate alert. The Minor Planet Center had flagged an anomaly. Observatories across 3 continents were reporting the same impossible thing. 3I Atlas had changed its trajectory. Not drifted, not been perturbed by some unseen gravitational influence. Changed. Deliberately, dramatically, and in a way that violated every principle of celestial mechanics we've established over 4 centuries of astronomical observation. Let me be absolutely clear about what I'm saying. Comets don't just change course. They follow predictable paths, dictated by gravity. The sun's gravity, the planet's gravity, even the subtle influence of their own outgassing as they heat up. We can model all of these effects. We do model them constantly for every object we track in our solar system. When Oumuamua passed through in 2017, it showed a slight acceleration that puzzled us, likely due to outgassing. That was strange enough to generate intense debate. But what 3I Atlas just did makes Oumuamua look like textbook physics. The numbers are staggering. 3I Atlas executed what can only be described as a course correction, a change in velocity of approximately 1.3 kilometers per second, altering its trajectory by 17 degrees. To put that in perspective, that's roughly the delta V needed to enter orbit around Mars from an interplanetary trajectory. For a comet with no visible propulsion, no exhaust plume, no rocket engines, this is impossible. The energy required to accelerate an object the size of 3I Atlas by that much would be equivalent to detonating several nuclear weapons. I immediately called Dr. Paul Kodas, the director of NASA's Center for Near-Earth Object Studies. Paul is the world's leading expert on orbital dynamics, the person who calculates asteroid trajectories for planetary defense. If anyone could explain this, it would be him. But when he answered, I could hear the disbelief in his voice. "Michio, I've run the calculations 17 times, he said. I've had my entire team verify them independently. There's no error. 3I Atlas performed a powered maneuver. It had to. There's no other explanation that fits the data. And here's what's really concerning. The new trajectory isn't random. It's precise. Calculated, the object is now on a course that will bring it significantly closer to Earth than we originally predicted." My blood went cold. How much closer? Our original calculations had it passing at approximately 0.8 astronomical units, about 120 million kilometers from Earth. A safe distance, nowhere near a threat. But with this course change, it's now targeting a much closer approach. Current projections put it at 0.15 AU, about 22 million kilometers. That's closer than some near-Earth asteroids, close enough for detailed study, but also close enough to be concerning. I flew to JPL the next morning and spent 12 hours in their mission control room, surrounded by the world's best astrodynamics experts. We reviewed every piece of data, examined images from multiple telescopes, analyzed spectroscopic signatures for any sign of outgassing or propulsion. What we found confirmed our worst fears and deepest suspicions. The maneuver occurred over a period of approximately 43 minutes. During that time, 3I Atlas showed no visible exhaust, no plume of gas or particles being expelled, nothing that would indicate conventional rocket propulsion. Yet it accelerated smoothly and continuously, altering its course with a precision that would be impressive for our most advanced spacecraft. The acceleration profile was nearly constant, suggesting a propulsion system with thrust control far beyond anything in our current technology. Dr. Jennifer Morrison, a propulsion specialist from the Jet Propulsion Laboratory, ran simulations comparing the observed maneuver to every known propulsion technology. If this were a human spacecraft, she explained, showing me her results, we'd need something like an ion drive running continuously for those 43 minutes. But even our best ion drives show visible ionized exhaust. We'd see it in the spectroscopic data. There's nothing, no thermal signature consistent with chemical rockets. No ion glow, no laser ablation effects. Whatever moved this object, it's using a propulsion principle we don't understand. The implications were obvious, though nobody wanted to say it out loud at first. We were looking at evidence of technology, not human technology, not natural phenomena. This was controlled, powered flight of an interstellar object, and it was now heading toward Earth with apparent intentionality. That evening, I participated in an emergency video conference with the National Security Council. The Secretary of Defense wanted to know if this represented a threat. The President wanted to understand what we were dealing with. I chose my words carefully, aware that what I said could trigger responses ranging from scientific mobilization to military alert. Mr. President, I began, we are observing an object that has demonstrated the capability for powered flight using technology we cannot identify or explain. It has altered its course to bring it closer to Earth. Whether this represents a threat, an opportunity, or something else entirely, we cannot yet determine. What I can tell you with certainty is that we are not dealing with a natural object following a ballistic trajectory. We are dealing with something that can navigate, that can change course, that appears to have a destination in mind. The questions came rapid fire. Could we intercept it? Could we communicate with it? Could we defend against it if necessary? I answered honestly, we didn't know. Our fastest spacecraft would take months to reach the 3I Atlas, and we had no idea if the object would perform additional maneuvers. As for defense, how do you defend against something that has already demonstrated technology centuries beyond our own? The world's response was swift and frankly chaotic. Within 24 hours of the news breaking, every major observatory on Earth was pointed at 3I Atlas. Space agencies that had been rivals for decades were suddenly sharing data, coordinating observations, pooling resources. The European Space Agency, Roscosmos, CNSA, ISRO. Everyone was working together with an urgency I'd never witnessed. For the first time in human history, we faced something that made our terrestrial conflicts seem petty and irrelevant. I found myself at the center of an unprecedented scientific mobilization. The United Nations established an emergency task force, the Interstellar Object Response Team, and asked me to serve as chief scientific advisor. I assembled a team of the world's best minds: astrophysicists, engineers, communications specialists, linguists, even military strategists and behavioral psychologists. We set up operations at a secure facility in Colorado, with direct links to observatories, space agencies, and government leaders worldwide. As we tracked 3I Atlas over the following days, we discovered more details that both fascinated and unnerved us. The object wasn't just approaching Earth, it was doing so along a trajectory that demonstrated sophisticated knowledge of orbital mechanics and gravitational assists. It had performed its course correction at precisely the right moment and with exactly the right magnitude to use Jupiter's gravity to modify its path. This wasn't random. This was navigation at the highest level, the kind of precision trajectory planning that our best mission designers spend months calculating. Dr. Sarah Weinstein, an expert in spacecraft navigation from JPL, was analyzing the trajectory with increasing amazement. "Look at this approach profile," she said, displaying a three-dimensional visualization on the main screen. "It's using a gravitational slingshot around Jupiter, then another micro-correction. We detected a small velocity change 3 days ago to set up what I can only describe as a parking orbit. If it continues on this trajectory without further changes, it will enter a stable orbit around the Sun at approximately 1 AU, the same orbital distance as Earth." "It's matching our orbit?" I asked, though I already knew the answer. Not just matching, it's positioning itself to maintain a relatively fixed position relative to Earth. At the closest approach, it will be stationary from our perspective, or as close to stationary as orbital mechanics allows. It's like pulling up next to us in traffic. This isn't a flyby. It's a rendezvous. The psychological impact on Earth was profound. Some people saw this as the greatest moment in human history, first contact with an intelligence from beyond our world. Others saw it as an existential threat. Religious leaders offered conflicting interpretations. Some claimed this was divine intervention, others a test of faith, still others a harbinger of apocalypse. Stock markets gyrated wildly. Social media exploded with theories ranging from the plausible to the utterly insane. But in our operations center, we focused on the data. What was 3i Atlas? What did it want? And most critically, what should we do? The object itself remained enigmatic. Spectroscopic analysis showed it was still reflecting sunlight like any comet or asteroid. Water ice, silicates, carbon compounds. But embedded within that ordinary surface, we were detecting anomalies. There were regions that seemed to absorb electromagnetic radiation across a broad spectrum. There were geometric patterns in the albedo, the reflectivity that looked artificial. And most intriguingly, we were still detecting that repeating signal, the one Harvard had discovered, broadcasting every 88 minutes without fail. Dr. Rebecca Chen, who had been analyzing the signal since its discovery, made a breakthrough that changed everything. The signal has modified, she announced during one of our daily briefings. After the course correction, the content changed. It's still repeating every 88 minutes, but there's additional information, and I think it's a countdown. She displayed her analysis. The binary sequences embedded in the signal now included a numerical progression that decreased with each transmission. When she extrapolated forward, the countdown reached 0 at a very specific time, the moment of closest approach to Earth. Now just 43 days away. A countdown to what? Asked General Patricia Morrison from the U.S. Space Force. That, I said quietly, is the question that could determine the future of our species. We intensified our efforts to decode the signal, to understand what 3i Atlas was trying to tell us. Teams of linguists, mathematicians, and cryptographers worked around the clock. We sent our own signals toward the object, simple mathematical sequences, images of Earth, representations of the solar system, anything that might establish communication. For 3 weeks, we received no response beyond the continuing countdown. Then, 17 days before the projected closest approach, something changed. 3i Atlas responded. It was 3:17 a.m. when the alert came through. I was asleep in my quarters at the operations center, but I was dressed and in the command room within 2 minutes. The main screen showed a new signal detection, this one different from the repeating 88-minute transmission. This was a one-time burst, highly directional, aimed precisely at Earth. The signal was complex, multi-layered, and clearly responsive to what we had transmitted. It contained our own mathematical sequences, sent back to us with elaborations and extensions. It included the images we had sent, but modified. Our image of the solar system now showed an additional marker, positioned at 3i Atlas's current location. Most remarkably, it included what appeared to be a three-dimensional schematic, a technical diagram of extraordinary complexity. Dr. James Okoro, our lead engineer, spent hours analyzing the schematic. When he finally briefed us on his findings, his hands were shaking. "This is a blueprint," he said. "Or more accurately, it's instructions. They're showing us how to build something. A receiver, I think, or possibly a transmitter. The design uses principles of quantum entanglement and what looks like manipulation of the zero-point energy field. If we could build this device, we might be able to establish real-time communication, regardless of distance." "They're trying to help us talk to them," said Dr. Elena Vasquez, stating the obvious but important conclusion. Over the next 2 weeks, a massive engineering effort began. Using the blueprint provided by 3i Atlas, teams at CERN, at Fermilab, at advanced physics laboratories in China and Japan, began constructing components of this communication device. It required precision manufacturing at the quantum level, materials science at the cutting edge of our capabilities, and engineering that pushed our technology to its absolute limits. With 4 days remaining until the closest approach, we completed the device. It looked nothing like conventional communications equipment. It was a lattice of superconducting quantum circuits suspended in a magnetic containment field, cooled to within microkelvin of absolute zero. When we powered it up, it began resonating at frequencies that seemed to reach beyond three-dimensional space into dimensions we could only describe mathematically. And then, 3 days before the closest approach, 3i Atlas spoke to us directly. Not in radio waves or light pulses, but through the quantum communication device, a stream of information poured into our systems. It wasn't language as we know it. It was pure conceptual transmission, mathematical structures and physical relationships that our computers struggled to translate into words. But the meaning was clear. They were not invaders. They were not a threat. They were explorers. Ambassadors from a civilization that had achieved interstellar travel thousands of years ago. They had been watching our solar system for decades, waiting for us to reach the threshold of technological capability that would make communication possible. The probe we called 3i Atlas was indeed artificial, a von Neumann probe, a self-replicating explorer designed to seek out emerging civilizations and establish contact. The course correction, the approach to Earth, the countdown. All of it was carefully calculated not to threaten, but to give us time to prepare, to understand, to be ready for what would happen when the countdown reached zero. They were offering us a choice, to join a network of civilizations spanning the galaxy, to share in accumulated knowledge of billions of years, to take our place among the stars. But the choice had to be ours. The countdown wasn't a threat, it was a deadline. When it reached zero, 3i Atlas would transmit the full archive, everything they wanted to share with us. But we had to choose to receive it. We had to choose to step forward into a larger universe. Standing in that operations center, looking at the data streaming from an object that had traveled across interstellar space to find us, I felt the weight of human history on my shoulders. We stood at a threshold that every civilization must eventually face. The transition from isolation to cosmic community. Einstein couldn't have imagined this moment, though his equations had helped us understand the universe well enough to recognize it when it arrived. In 3 days, the countdown would reach zero. In 3 days, everything would change. And I, Michio Kaku, physicist and dreamer, would be privileged to witness humanity's greatest transformation. The universe had reached out to us. Now we had to decide, would we reach back?